Black holes are some of the most mysterious and terrifying objects in the universe. They are so dense that not even light can escape their grasp. But have you ever wondered, what would actually happen if you fell into one? Would you be stretched into spaghetti? Would you be crushed into nothingness? Or could you somehow survive and see what lies beyond? Scientists have long studied black holes, but no one has ever come close enough to experience one firsthand. With gravity so powerful that it bends space and time, stepping into a black hole is like entering a different dimension. The laws of physics break down, time slows to a crawl, and the very fabric of reality distorts in unimaginable ways. Some theories suggest that falling into a black hole could lead to a gateway to another universe, while others claim it would mean instant destruction. But the truth is much more complex. As you approach the event horizon, the point of no return, strange and terrifying things start to happen. Your body would stretch, your surroundings would twist, and time itself would behave in ways that defy logic. But what would happen next? Would you disintegrate? Would you reach a singularity and cease to exist? Or could you actually experience something beyond human understanding? In this video, we will explore the mind-bending reality of what happens if you fall into a black hole. Before we begin, hit the like button, subscribe to the channel, and turn on notifications so you don't miss more mind-blowing space explorations. Now, let's dive into the abyss and find out what awaits inside a black hole. 1. Approaching the black hole. The journey begins. Imagine floating in deep space, slowly getting pulled toward an invisible force. At first, you may not even notice anything unusual. The stars around you still shine brightly, and space appears normal. But as you drift closer, the view begins to change. The immense gravity of the black hole bends light around it, distorting the space behind it like a cosmic funhouse mirror. This effect, known as gravitational lensing, makes distant stars appear stretched and duplicated. As you continue falling, the gravitational pull intensifies. The closer you get, the faster you accelerate, drawn toward an invisible abyss. At first, you try to resist, but the force becomes overwhelming. The speed increases beyond anything a human has ever experienced. You are now moving at a significant fraction of the speed of light. The feeling is terrifying, yet strangely silent. Space itself provides no resistance. You are being pulled into something from which there is no return. 2. The event horizon. The point of no return. The event horizon is the ultimate boundary of a black hole. Once you cross it, there is no turning back. No spaceship, no force, not even light itself can escape from this invisible barrier. If an outside observer were watching you fall, they would see you slow down, as if you were frozen in time at the event horizon. But from your perspective, you would fall right through without noticing anything strange. As you pass this threshold, space and time behave in ways that defy understanding. Everything around you seems distorted, and the laws of physics as we know them start to break down. You try to look back, but the outside universe appears frozen, as if time has stopped. Meanwhile, you are still falling, deeper and deeper, into the unknown. There is no way out now. You are trapped in a one-way journey toward the singularity. 3. Time dilation. Experiencing time in slow motion. One of the strangest effects of black holes is time dilation. Due to their immense gravitational pull, time moves much slower near a black hole than it does for an observer far away. If someone were watching you from a distance, they would see your fall slow down, as if you were moving in extreme slow motion. But for you, time appears normal. You don't feel anything unusual. However, if you could somehow look back toward the outside universe, you would witness something shocking. The entire future of the universe would play out before your eyes. Stars would form and die, galaxies would collide, and billions of years would pass in what feels like seconds to you. The deeper you go, the more extreme this effect becomes, until time itself loses all meaning. 4. Spaghettification. The stretching effect. One of the most terrifying effects of falling into a black hole is something scientists call spaghettification. The gravitational pull on the part of your body closest to the black hole is much stronger than the pull on the part farther away. This causes an extreme stretching effect. Your body would begin to elongate like a piece of spaghetti. As the stretching continues, the forces become unbearable. If you were falling feet first, your legs would be pulled away from your torso, and the difference in gravity would start ripping you apart. Within moments, your body would be reduced to a stream of atoms, spiraling endlessly toward the singularity. This is the horrifying fate of anything that dares to fall too deep into a black hole. 5. The singularity. The unknown abyss. At the heart of a black hole lies the singularity, a point of infinite density and zero volume. Here, the very fabric of space and time collapses into nothingness, and the laws of physics cease to make sense. No one knows what happens at this point. Some theories suggest you would be crushed out of existence, while others believe a new reality could emerge. Could the singularity be a portal to another universe? Could it lead to a new dimension where different laws of physics apply? Or does everything simply end here, erased from existence? The truth remains one of the biggest mysteries in physics. 6. Are black holes wormholes to other universes? One of the most fascinating theories is that black holes could be wormholes, gateways to other universes. Some physicists believe that instead of being destroyed, matter falling into a black hole could be transported to another reality. If this is true, then black holes could be portals to new dimensions, offering a pathway to places we can't even imagine. Could falling into a black hole mean entering a parallel universe? Could civilizations exist on the other side of a black hole, living in a completely different reality? The possibilities are mind-blowing. 7. Hawking radiation. Do black holes evaporate? Despite their reputation for being inescapable, black holes don't last forever. Stephen Hawking's groundbreaking theory suggests that black holes slowly evaporate over time through a process known as Hawking radiation. According to this idea, black holes emit tiny particles due to quantum effects near the event horizon, gradually losing mass and energy. But what does this mean for black holes? Over trillions of years, a black hole could shrink and eventually vanish entirely. However, the process is incredibly slow for massive black holes. If you were inside one, would you notice anything different? Likely not. Hawking radiation is weak compared to the immense gravitational forces at play. Yet, this discovery reshaped our understanding of black holes, proving they are not eternal after all. 8. Inside the black hole, a new reality? If you somehow survived the initial fall and crossed the event horizon, what would you experience inside the black hole? According to Einstein's equations, space and time become so distorted that they effectively switch places. Instead of moving through time normally, you might find yourself trapped in a singular timeline, unable to change direction. Some scientists theorize that the inside of a black hole could be a bubble of warped space, where unknown physics rules apply. Could entire worlds exist beyond the event horizon? Some suggest that black holes might contain hidden universes, where reality is completely different from what we know. The problem? We may never know for sure. Nothing escapes to tell the tale. 9. Supermassive black holes. The monsters of the universe. While black holes can form from collapsed stars, the largest ones, supermassive black holes, exist at the centers of galaxies. These cosmic giants can have masses millions or even billions of times that of the Sun. The Milky Way's central black hole, Sagittarius A, is one such behemoth. If you fell into a supermassive black hole, your experience would be vastly different from falling into a smaller one. The immense size means the tidal forces near the event horizon are weaker, meaning you wouldn't feel the immediate effects of spaghettification. You might even cross the event horizon without realizing it, but the end result is still the same. You're trapped with no escape. 10. White holes, the opposite of black holes? What if black holes had an opposite counterpart? Some theories suggest that white holes could exist, a hypothetical phenomenon where, instead of pulling everything in, they push everything out. In essence, a white hole is like a time-reversed black hole, spewing out matter instead of consuming it. Could a black hole be connected to a white hole, forming a tunnel across space and time? This idea has led to speculation that white holes could be the exit points of black holes, acting as cosmic shortcuts through the universe. If that's true, falling into a black hole might not mean destruction, but instead, a journey to a distant part of space, or even another universe. 11. The nature of gravity inside a black hole, intense forces at play. Once inside a black hole, gravity becomes something entirely different. Its immense force distorts space and time, creating a warped reality that is beyond human comprehension. As you fall deeper, the force of gravity becomes so powerful that it pulls not just physical matter, but the very fabric of time itself. It creates a universe where no laws of physics can predict the outcome. Gravity here is so strong that it crushes everything, including light itself. As you approach the singularity, you feel this force building upon you exponentially, eventually becoming overwhelming. 12. The black hole's event horizon, the point of no return. The event horizon of a black hole is the ultimate threshold, where everything changes. Once you cross this point, it's impossible to escape. Any light, matter, or energy that passes through is lost forever. From an outside observer's perspective, your descent into the black hole appears to slow, and you seem to freeze as you reach the event horizon. However, from your perspective, it would be impossible to notice any change. Time, space, and gravity all behave unpredictably beyond this point. The event horizon marks a dramatic separation between what is known and what is unknowable. 13. What happens beyond the event horizon, the unseen reality? Beyond the event horizon, the universe as we know it no longer makes sense. This mysterious region is where time and space bend in ways that challenge our understanding of the laws of physics. Inside the event horizon, the force of gravity is so intense that it warps the flow of time itself. Time may slow down to an almost imperceptible crawl, or potentially stop altogether. What happens beyond this point is unknown, but the most likely outcome is that you'll approach the singularity, a place where time, space, and everything else collapse into a singularity. 14. How black holes are formed, the birth of cosmic giants. Black holes form from the collapse of massive stars that have run out of fuel. When these stars no longer have the energy to support their own gravity, they implode, and their core contracts under the weight of its own mass. This implosion causes a rapid increase in density, creating a singularity. If the star is massive enough, the collapse leads to the formation of a black hole. The intense gravitational pull from the singularity causes the surrounding space to warp, trapping anything that comes too close. These cosmic giants continue to grow by absorbing matter and energy from their surroundings. 15. Supermassive black holes, the giants at the center of galaxies. Supermassive black holes are the largest and most powerful black holes in the universe, residing at the center of most galaxies. These behemoths have masses millions or even billions of times that of our Sun. It's believed that they formed in the early universe, growing over time by merging with other black holes and absorbing vast amounts of gas and stars. Supermassive black holes have an immense gravitational pull, which influences the motion of stars and gas around them. They may also play a crucial role in galaxy formation and evolution, making them some of the most mysterious objects in the cosmos. 16. The potential of white holes, the opposite of black holes. Could black holes have an opposite counterpart? Some scientists speculate that white holes might exist, a phenomenon where instead of pulling everything in, matter and energy are expelled. White holes are a theoretical concept, like a time-reversed version of black holes, sending material out into space instead of consuming it. The idea is that a black hole and a white hole could be connected, creating a bridge between 2 points in space-time. This concept suggests that instead of being destroyed by a black hole, matter might be sent to another universe or distant part of the cosmos, potentially offering a way out of the black hole's grasp. 17. Theories of what happens inside a black hole, exploring the unknown. What exactly happens inside a black hole? No one knows for sure, but scientists have proposed several theories. One suggestion is that the singularity at the center of the black hole is a point of infinite density, where all matter is compressed into a single point. However, this creates contradictions in our understanding of physics. Some theorists speculate that black holes may actually be gateways to other universes, or they could connect different regions of space-time. The possibility of black holes containing entire parallel universes is one of the most fascinating ideas in astrophysics, though we may never know if it's true. 18. Black hole accretion disks, feeding the monster. Around many black holes, particularly supermassive ones, lies a swirling disk of gas, dust, and other matter, known as an accretion disk. As matter falls into the black hole, it accelerates and heats up, emitting intense radiation in the process. The material in the accretion disk can reach temperatures of millions of degrees, making it one of the hottest regions in the universe. This process is incredibly violent, and the energy produced can be detected across vast distances. The accretion disk plays a key role in the behavior of black holes, contributing to their growth and their ability to affect their surroundings. 19. Can we detect black holes? How scientists observe the invisible. Despite being invisible, black holes can be detected using indirect methods. The most common technique is observing the effect a black hole has on nearby stars and gas. When a black hole pulls in matter, it emits X-rays and other high-energy radiation. Scientists can also detect gravitational waves, which are ripples in space-time caused by massive objects, such as black holes, merging or moving. One of the most famous detections occurred in 2015, when scientists recorded gravitational waves from the merger of two black holes. These observations have opened up a new window for studying black holes, giving us insights into some of the most enigmatic objects in the universe. 20. The future of black hole research, unraveling the mystery. Black hole research has come a long way, but we are still far from fully understanding these cosmic mysteries. Advancements in technology, such as the Event Horizon Telescope, which captured the first image of a black hole, have pushed the boundaries of what we can observe. In the future, scientists hope to learn more about the inner workings of black holes, their formation, and their role in the universe. The study of black holes could lead to groundbreaking discoveries about gravity, time, and space itself. The mysteries of black holes are far from solved, and as technology continues to evolve, so too will our understanding of these fascinating objects. As we conclude our journey through the mysterious depths of black holes, we are reminded of how little we truly know about these cosmic enigmas. Black holes challenge our understanding of the universe, pushing the boundaries of physics and reality itself. From their formation in the death of massive stars to their possible connection to other universes, black holes hold many secrets that we are only beginning to unravel. As we've explored, these fascinating objects offer us a glimpse into the unknown, where time, space, and gravity behave in ways that defy all logic. While we may never be able to experience the mind-bending effects of a black hole firsthand, the theories and discoveries we've discussed today remind us of how much more there is to learn about the universe. Perhaps, in the future, we will gain new insights that will forever change our understanding of the cosmos. The beauty of black holes is not just in their immense power, but in the fact that they provoke questions that drive scientific curiosity and exploration. Will we one day discover a way to traverse their depths? Could they hold the key to understanding the fundamental nature of our universe? Only time will tell. As we continue to explore the universe, one thing is certain: black holes will remain a key part of that exploration, challenging our minds and expanding the limits of what we thought was possible. It's a reminder that even in the most terrifying and mysterious corners of space, there is always more to discover. If you enjoyed this deep dive into the universe's most fascinating objects, don't forget to hit the like button and subscribe for more mind-bending space explorations. Turn on the notification bell so you never miss an exciting journey into the unknown. We've only scratched the surface of what the universe has to offer. So, until next time, keep exploring, keep questioning, and stay curious about the universe that surrounds us. Thank you for watching.